Lesson 8-5, Factoring x squared plus bx plus c. This right here is a trinomial. We've seen these before. We are going to learn in this lesson to factor it. When they ask us to factor a trinomial in this specific form, they're looking for two factors or two binomials, which are two polynomials that have two terms in them that can be multiplied to get this trinomial. Basically, in this lesson, we are going to be undoing the FOIL method. Let me show you what I mean. So when you have a trinomial like this, you can find two binomials that factor together to equal that trinomial. To factor a trinomial in this form, x squared plus bx plus c, you must find two numbers that have a sum of b, so two numbers that equal the middle term, and a product of c, two numbers that multiplied together equal c. Let me show you what I mean. Alright, so remember we're undoing the FOIL method. Okay, so we're going backwards. So in this first example, they give us the trinomial x squared plus 8x plus 15. When they ask us to factor that, we're looking for the two binomials that can be multiplied together to get this trinomial. So the first thing they want, remember, my trick for you is to look at the third term, the constant. You want to find two numbers that can be multiplied together to get that number, and those same two numbers should be able to be added together to get this term, or 8. So what they did is they first looked at 15. Well, what numbers can be multiplied together to get 15? Well, 1 and 15 and 3 times 5 equal 15. Okay, well, since we can only use one set of the numbers in our binomial, which ones have a sum of 8? Well, 15 plus 1 is 16 and 5 plus 3 is 8. This set of numbers will work. So, undoing the FOIL method, I get x and x, because if I FOIL first terms, x times x would give us the x squared. Then I need to multiply to get a positive 15. Well, I'm going to use a positive 5 times a positive 3. You can always check your work by FOILing to see if you get your original trinomial. So x times x is x squared. 5x plus 3x, outside inside, is positive 8x. And then last terms, 3 times 5 is a positive 15. So that works. Let me show you another example. What is the factored form of r squared plus 11r plus 24? Remember, when it's in this form, you have two binomials. The r squared is always going to be just an r and an r, because multiplied together you'll get your r squared. What are two numbers that have a product of 24? Well, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all the factors. Now, between these four choices, which one adds up to 11r? Or 11. Well, this one doesn't. 12 plus 2, nope. 6 plus 4 is 10. 8 plus 3 is 11. So positive 3 times positive 8 equals 24, and positive 8 plus 3 is 11. Here's our factored form. Alright, sometimes the trinomial will have a negative coefficient of x and a positive constant term, meaning this middle term here is negative. So in that case, to get a negative sum, that changes it up a bit. So in this example, they needed two factors of 24, so they listed them all here. Now, because we have a negative number that we need to add up to, they found all the factors that are both negative, because two negative numbers will add up to a bigger negative number. So they, instead of choosing 1 and 24, they chose negative 1, negative 24, negative 2, negative 12, etc. They found that negative 3 plus negative 8 equals this negative 11, and it also equals 24 when you multiply. So their final answer was x minus 3 and x minus 8. Let me show you an example. What is the factored form of y squared minus 6y plus 8? Well, starting with my two binomials, my first term is y squared, so I have a y and a y as my first term. I need my two numbers to multiply to 8, 1 times 8 perhaps, 2 times 4, but they need to add up to a negative 6. Alright, so thinking here, if I had both of these negative, negative 4 times negative 2 still equals a positive 8. And when I add them, it's a negative 6, so this will work. Negative 4, negative 2. This is my factored form of the trinomial. If I want to check my work, just FOIL. First term, outside, inside, and last. And it matches. Third example, sometimes C, or your constant, is negative, so that changes things too. In this example, we need a product of negative 15. Well, a negative number, it must be a negative times a positive. So they did 1 and negative 15, or negative 1 and 15, 3 and negative 5, or negative 3 and 5. These will all have different sums when you add them together, based on which number was negative. They found that the negative 3 plus a positive 5 gives you that positive 2x. So their final factored form was x minus 3 times x plus 5. Here's another example. A. All right, it's in the trinomial form. I'm putting my n's first. I need to equal negative 36. Well, so one of these is going to be minus and one of these is going to be positive. That's how I get a negative product. I have to equal positive 9. Well, I have to think about what can I multiply to get negative 36. Negative 1 and 36. Negative 2 and 18. That's not going to add up to 9. Negative 3 and 12. Let's think about those two numbers. Those multiply to negative 36. Which way do I need to write them to get positive 9? Well, a negative 3 plus positive 12 will get me that positive 9. So n plus 12 times n minus 3 is the factored form. All right, how about the second example? Two binomials, c squared, so they're both a c, need to equal negative 21. Well, I know that 7 times 3 is 21. One of them will have to be negative for my product to be negative, and I need a negative 4 for a sum. If I do a negative 7 plus 3, that would equal negative 4. So I'm going to do c minus 7 and c plus 3, and that will equal my trinomial. Remember, always FOIL to check your work. Final example is just applying this to an area problem. So for example, a rectangle has an area of x squared minus x minus 72. What are possible dimensions of the rectangle? So what's the length and the width? What are two, basically we want to factor this trinomial. Well, I can create two binomials, x and x. One could be the length, one could be the width. I need to get a negative 72. Well, 9 times 8 is 72. One of them needs to be negative, one of them needs to be positive to get the negative product. I need to equal a negative 1. Well, negative 9 plus 8 will leave us at negative 1. So I'm going to fill my numbers in accordingly, and those are the two dimensions of my rectangle. All right, final example. Factoring a trinomial with two variables. Notice you see the xy. So there's an x squared, a y squared, and an xy. Really nothing changes. It's just that each term, this one includes an x and a y, an x and a y. Let me show you what they did here. I'm just going to show you right at the got it. So I'm just going to factor m squared plus 6mn minus 27n squared. Well, I'm going to create my binomials. M squared is m and m. To get the n squared at the end, it's going to be something times n, because then when you multiply them in the middle, the outside and inside terms is m times n and m times n. That's how you get this middle term. So still doing the product and the sum, same as we have been. So what numbers equal a product of negative 27? Well, I'm going to jump right to 9 and 3 because I know those factors equal 27. One of them will have to be negative and one will have to be positive. To get a sum of 6, if I have a negative 3 and I add 9, I'll get a positive 6. So I'm going to do m minus 3n and m plus 9n. And that should be my final answer. The two binomials, or the factor, is m plus 9n times m minus 3n. Go ahead and check your skills by completing the lesson check number 1 through 5. Go back and rewatch if you feel the need. Good luck!